Tonight we have with us a very special speaker. He is both a techie and serial entrepreneur with more than 20 years of tech product management. He's got a PhD in distributed systems. Please welcome the CMO of Couchbase, Dr. Howells.
Thank you. As just said, my background, so I originally did research into distributed database systems and on the Produce project in the 80s. And in those days, if that's what you've done, there was one thing you wanted to do was go and work for Lightstone. When I started to invest in the 80s, I was there for about 6 years. And I think some real parallels to what happened in the database industry in the 80s and what's happening today. What we saw then was a real shift in hardware and moving towards vast computers. Relational databases were just fundamentally better on many computers. They would annihilate the legacy database platforms. Also, they were fundamentally better at certain use cases. We're only going to see a big customer, they'd be waiting 6 months for this application to be written on an SQL query in 30 seconds. So it just blew away the incumbents. Relational databases just got better and more generalized and more use cases and ended up eating away the market of code on RMS. If you roll that forward to today, what we're seeing is a shift to loosely coupled, shared nothing architectures, cloud architectures. NoSQL databases are just fundamentally better in that architecture. There are certain use cases that they're just fundamentally better at. And what we're seeing is a shift that they're becoming generally better and better at more and more use cases. And they'll start to eat away at Oracle, DB2, Microsoft. What I'd like to talk about today is those use cases. And look at some examples from people like PayPal, people like QuestPoint, people like LivePerson, and how they've used NoSQL. And then look at, in the second half of the presentation, the technology that enables that. Because these choices were made because NoSQL is just fundamentally better than doing it with a relational database. So I'd like to briefly talk about Couchbase. Look at predicting the future. So I think some ways you can do that to be pretty accurate. Look at those use cases and patterns that are particularly good for NoSQL. Then after we looked at that, look at the kind of performance numbers that these customers have got, look at how NoSQL works to do that easily. As part of the big thing is it makes it painless to get kind of scalability and performance that you need. Then look at the future of NoSQL. We believe NoSQL is going to move to mobile. And you'll have NoSQL on the device, on the wire, and in the cloud. Really look at what we're going to be working on there. Just briefly, very quickly about Couchbase. We're a leading NoSQL company. A little kind of parallel you can do back to the 80s. So if you were working in that industry, there were tons of relational database systems. Then you kind of got a pack. It was Oracle, Informix, and Ingress. And they kind of got the lion's share of everything. And if you roll that forward to today, the packs kind of form. It's Mongo, DataStax with Cassandra, and Couchbase. Those are the equivalent big three around NoSQL today. So there are different types of NoSQL database systems. And I'll bring up a slide of that later on. But we focus on key value, so you really high performance for that, and a document JSON database as well. What we focus upon being best of breed at is giving you very, very easy scalability and very consistent high performance. So, for example, if there's a write in the system, we don't lose performance. We've got actually over 400 customers now. We've got over 10,000 paid production nodes. And we see the whole NoSQL in our industry, not just Couchbase, will significantly disrupt the Oracles, DB2s, and Microsoft SQL servers that are out there. As we said, one of the questions will be we're headquartered in Benari. Stuff about Couchbase. I think what's really interesting when you look at NoSQL, predicting the future, one of the things to look at is these companies. We call these companies the masters of the internet. If you look at what they're really masters of, the masters are taking commodity hardware, putting it in a very loosely coupled shared networking architecture, and getting awesome scalability, awesome performance. They don't go down, they have rolling upgrades, and they can change schemas and you don't even know it's happening. They have monthly rollouts. These guys are pretty much what most companies would love to be like. And if you look at those companies independently on their commodity hardware architecture that are loosely coupled, came to the same conclusion. For certain web apps, you have to have NoSQL. And the pain was that great, they wrote their own. So I think it's pretty unquestionable that these kind of architectures for web and we'll see in the future mobile apps, you fundamentally have to have NoSQL. And these companies needed it so much they wrote their own. But the part of the problem for the rest of us is we haven't got 1,000 Berkeley, Stanford PhDs write databases for us. So to get these kind of levels of performance and scalability, the industry is packaging up NoSQL for general purpose usage within enterprises and internet companies. So what I'd like to walk through now is some of the early use cases where NoSQL is just fundamentally better. Not just a little bit better, it annihilates relational database systems. So the first kind of common use case is kind of interesting around social gaming. So you think about OG Pop, it went from 50 to 50 million users in 50 days. You think about most enterprises, they couldn't buy the hardware in 50 days to do that. What was interesting about that game, it was phenomenally successful, and it just grew in a cloud-based architecture. A much bigger brand game company put out a game at the same period of time, and it was phenomenally popular. So popular the system crashed and they pulled it from the market. So the only way you're going to get this kind of unpredictable scalability that you should roll out on demand is typically with NoSQL systems and a loosely coupled shared learning architecture. The other kind of thing about mobile apps. If my mobile apps only ever worked when I was connected to the internet, and if I made changes when I was offline that didn't get reflected online, I think it was a pretty useless app. So we're being conditioned to have certain expectations around mobile. And that's not always being connected to an app on the internet. So let's talk about that later in the presentation, around how you use JSON on the device, JSON in the cloud, and JSON on the server. But kind of put in your mind, you think about how powerful the latest Apple devices are. You think about all the people using mobile phones. Some of the compute power on the mobile phones is going to equal that in the cloud. So are we going to waste it, or are we going to have really cool data-intensive apps on these mobile phones, which we believe we are going to have, that work both online and offline? The other one is, people in this room are probably going to be very familiar with this, ad targeting. So we think about the classic example is you go to Zappos, your wife was on Zappos to buy a pair of shoes. She puts it in the cart and somebody phones her. So she leaves it in the cart. It's kind of weird. The next day, you go to a totally unrelated site, not only do you see shoes being advertised, but the same pair of shoes. And then you kind of go to Google Mail the next day, and you see not only the same pair of shoes, but a discount voucher for 10%. So what's happening is you're being tracked across websites. And there's this space available that people do real-time bidding for, and they'll bid for that. And that has to be phenomenally quick. So if you can do that in sub 10 milliseconds, people will bid very good money for that. If you're slow, you just put a random ad there and get no money. So you have to have phenomenal performance to do that kind of thing for ad targeting. The other kind of thing is a session store. We're going to look at one example from, people haven't heard of the company Live Person. I'll guarantee pretty much most of you have used it. So when you go to the AT&T site, Bank of America site, or the Verizon site, you see a pop-up window, which certainly chats to you. What they've been doing is, in real time, tracking your behavior, predicting, are you going to buy, are you going to complain, or are you going to terminate your contract? And they have to be able to track that session store in real time, so that when somebody talks to you, they have a context of what they believe you're going to be doing. User profile stores are kind of interesting. So you think about when you PayPal, we'll talk about later. They know your PayPal profile, your eBay profile, or the social profiles. They build this social profile that aggregates data from many different sources. So if you log in, they know a great deal about you. They can target you with particular ads, particular promotions, and what you're really doing then is doing that again in sort of this 10 millisecond time frame to know exactly the profile of the person, and you're aggregating data sources from many different places. Same for many, many e-stores. That's how they predict what you're going to buy, and they can suggest what you're going to buy as well. But again, what's critical there is awesome performance in kind of the 10 millisecond range. Otherwise, it's just a waste of time. But we're going to talk about caching. And we'll look at this. This is kind of stuff like what Orbit's doing. So when you're looking on a travel site, you get very, very good performance. It can remember the data you asked for, remember your previous searches. That's another classic use case of NoSQL. The other one is great. We've got Christopher C. from Howells here today, looking at how you do content and metadata storage. And that's what McGraw have done for training. So we'll talk a little bit about that. Christopher's here if you want to talk to him later as well about how they do training with online videos, with metadata around that, tracking the students, do that on a global scale. Finally, the one is around third-party data aggregation. we think about one of the problems we've traditionally had, we've got to jump through horrible hoops. So I may have 3 different systems, and then each of the 3 different systems represents people in a different way. So it's kind of a pain to aggregate tables that are all different. So what we're able to do is, if you can map them to 3 JSON data structures, you just aggregate them, and each row has a slightly different structure. But you can look at it without having to harmonize your schema, which is just people spend years trying to do, which never works in a large organization. So what I'd like to talk about is some of those use cases, because big companies do not just one of those use cases, they always do a combination of them. And walk through 3 examples from PayPal, Westpoint, and LivePerson. So you look at why those customers and why people in general move to NoSQL. It's for hanging around scalability, hanging around performance, hanging around just changing your schema. And you look at what people have done over the last 10 years. If we'd been having this presentation 10 years ago, we'd be talking about the LAMP stack. And LAMP was great because it's really simple, it's cheap, you can roll it out, and moderate scale is great. Then you think about what we've done over the last 5 to 10 years is, we talk about sharding because it's really, really painful to scale. So you shard your system across multiple MySQL systems. Then when you run out of capacity, you rewrite your app. And then you rebalance the database. You delete half of it, move it over here. Painful, painful, painful scalability. You think about the LAMP stack, when you want performance, people have become masters of the art of using memcached or caching. If they want to get really good performance, they maybe plug SSDs in the back end. And suddenly scalability becomes phenomenally expensive. So your success kills you from a cost perspective. If you look at agility, certainly the games industry, they want to be able to add new kind of bullets or new kind of gems that they can sell. And they want to be able to change the schema. You don't want to be able to have to bring your system down, do an alter table and bring it up again. You want to be able to do that instantly. So we think about the LAMP stack was Linux, Apache, MySQL, PHP. As it grew over time, it became Linux, Apache, MySQL, and Paint. And that's really what NoSQL is replacing, is that kind of situation. So what we're going to talk about is these 3 customers and also McGraw-Hill. How we've gone from that to this. That's really what MySQL is designed to do. It's to make it really easy to scale, make it really easy to get consistent performance, make it really easy to dynamically change your application, your schema. Those are the real drivers of why people use NoSQL. That's where it's fundamentally better. Also, it's great when our customers here, Chris Lee from McGraw-Hill Labs, so we can talk about what he's been doing. You see about some questions afterwards as well. And what they do there is around online education. So what I've taken is some of the essence of some of the presentations that are, there are big 40-minute videos available on couchbase.com/presentations, if anybody wants to look at them. What I've taken is the essence from some of the presentations that these speakers have spoken about. So the first was QuestPoint. And I think, irrespective of the use case, you're probably doing a combination of use cases. One of the raw pains is just scalability. And scalability that's easy without jumping through hoops or killing your budget. QuestPoint's really interesting. So QuestPoint ingests data from the internet in real time to predict who does what online and when and how they do that. They do traffic arbitrage, affiliate marketing, lead gen, and then they do, for QuestPoint Decision, they do insights for major brands like Coca-Cola to tell them how effective their ads are, to do media planning and insights on what the audience is doing. So the volumes here are just massive. To give you a feel of the pain they were going through, they had 62 terabytes of network traffic per day. They were doing 11 billion transactions per day. They had 6.1 million user connections. And every time they had to scale out, they were using SQL Server, they had to add the hardware. And then they had to take the database, split it into 2, copy half of it across here, delete the half of here. It was just complex was the polite way of doing it. It was just a nightmare. They were having queries from a performance perspective that took 12 hours. If you're going to be providing up-to-the-minute intelligence, information that's 12 hours out of date is kind of not great. And the only way they could get the performance they were needing was to have Dell blades. For each Dell server they had to have a Fusion IO card, which was twice the cost of the Dell server. So they were doing phenomenally well, they were growing really well, but the cost of growth was killing them, because the only way they could get it was with SSDs. So they moved to commodity hardware. Now they can rebalance their systems in minutes, not hours, with a single click. because that's what NoSQL is very good at doing. They're doing about, they have the potential and capacity, which obviously varies, to do 1.5 million operations per second, and they just scale easily. There's no headaches. Every time they need to scale up, they just add more commodity hardware, and they just get more scalability. It automatically reorganizes itself. We'll go through some of that, how we do that later. The other thing is they took their queries from 12 hours to 5 minutes, which is a massive performance increase. And probably as important as anything, they were able to get way better performance, way better scalability on commodity hardware with no Fusion IO cards. So the cost was like 32% less. So you had better, faster, cheaper. And that's pretty common, so pretty much every use case is going to need that kind of simple scalability. Now when I go through these use cases, it'll be interesting to look at the patterns and what we're seeing. What we're seeing here is really a combination of batch, which is typically Hadoop-based, and you're seeing real-time serving of typically JSON data or key-value data from a NoSQL system. So I believe we're moving, the stacks are changing from a LAMP-based stack, evolving over time to a new batch-based stack and a real-time stack. And we're going to see that the architecture of these three customers, there's some patterns I think are starting to emerge. Next one is live person. And again, this is probably, we've all used this kind of system. It's used by most of the big BofA, Verizon, AT&T. And they do large scale real-time analytics, also managing the session in real time as well, to predict what you're going to be doing. So this is a Verizon site. So when you go to this Verizon site, depending upon the pages you look at, how long you stay on the site, your previous history, how long you stay on certain pages, they can predict what you're going to be doing. So they need help with your order. For example, they're predicting they believe you're going to buy. And they give you rich multimedia to support that as well. So they're doing real-time serving of content based upon predictive analytics and your behavior. They can predict you're going to terminate your account, they can predict you're going to complain. They'll associate you with the appropriate person, maybe a customer support person for a complaint, or a salesperson to sell you a new phone. This is all happening in real time. If this was slow, you'd never use the system. So you think about some of the volumes that they're dealing with. They have 30 terabytes per month. They call it 20 million engagements. Now, an engagement may be many, many interactions. You think about the interaction of tracking a user, every place they go to, how long they're looking at it, what they've done previously. So they reckon each interaction is about 200 separate pieces of information you have to track. About 1.8 billion sessions per month. So scalability is a massive issue for this kind of customer. The other thing they're doing is they're combining batch analytics and real-time access to customer profiles. And again, that's a consistent thing that we're seeing here. How can I get a profile of you and understand you and serve you in real time better? And they also be able to model you. And again, they were using the JSON object model to do that, which is becoming more and more common throughout all these applications. So we look at what they were doing. In the past, you were talking to someone and you'd have to say, hello, this is my name, this is what I've looked at, and describe yourself. Because the person on the phone would know nothing about you, or the person on the chat line would know nothing about you. So they wanted to fundamentally change that, to be able to track all the visitors' events, so that the person, the first time they engage with you, knew a lot about you, and could serve you way better with better context. So they were starting to have an event bus to track every single event, every single activity that you did on the website. The first architecture that they had was around using Tomcat, Couchbase, and Couchbase within clusters across multiple. They have 4 data centers globally. They use Couchbase for MapReduce analytics. They're using Storm for topology as well, and the Java SDK. So we look at the flow around that. A visitor would come in, they would browse, we'd capture every single event and the time of every event and the sequence of the events. Then they feed those into Couchbase and they analyze the relevant events. Then they write the events into Couchbase, and the agent will get the visitor list every 3 seconds that was up to date. And if it was a relevant visitor, then they start doing some activity around that. They'd store that information in Couchbase and give it to the rep. And that rep would know the whole context of what that person had been doing in the past, what they've been looking at, how long they've been looking at it for, so you can have an initial conversation with complete context. This is all done in real time. This is what I find interesting. You look at the stack again. What we've got is a real-time stack and a batch stack. In the real-time stack, you've got store and Couchbase. So Couchbase is serving up that information about that user and what they've done recently and what they've done previously in real time from the operational data store. If you're at the batch stack, you can do what you're already using Hadoop for is obviously for analytics, but the other thing is how do I gather relevant information around a single person and bring it together and feed it into the operational data store. And that's again feeding into Couchbase, but also using Couchbase for the MapReduce views to do real-time analytics on the spot for the customer rep, feeding to the customer rep to give them context around the customer. So PayPal is an amazing company. They're using us for many, many different things: session management, analytics, global profiles, user IDs. What I like to look at is one of the things they're doing. Most big companies, I believe, are going to be doing combinations of those use cases that we saw, because they're all very related to each other. And you get benefit from doing the first time you do one of them, the second one is way easier than the third one is way easier as well. So I like to look at what PayPal are doing around global user IDs or user profile management. This is a common use case across any e-commerce internet site. This is what they're all aspiring to do. So what they're able to do is they want to know everything about you to give you better service. So they're able to look at your PayPal user ID, also merge it with your eBay user ID, social platform information, third-party user IDs, maybe email, home address and phone numbers. So they get a real whole picture of you, which means they can give you much better customer service. Now you think about that, it means you're already bringing in information from multiple data stores that may be independently changing. So if one of those data stores changes, you don't want to bring your database down, do an alter table, and import everything in, and then 2 days later your system comes back up. Because the scale of this, it would take a long, long time to do that. So they need to be able to be agile in real time, change their data structures, and model it far more effectively. So what you're seeing is most modern organizations, particularly ones that do mobile development, are using JSON. So it's pretty much become the standard way to do this model. So what they're able to do is to take this information, match the key, the value, and store it in a JSON object. So then what they're able to do is to be able to do the most relevant offer, coupon, or awareness ad based upon that kind of information around your user profile, and consistently give it to you across Facebook, your laptop, your mobile device, or email. And then learn more and more about you to give you better and better service as well. It's kind of interesting. Look at the kind of scale that these guys have. They have 300 billion to 1 billion documents, JSON documents, 3 terabytes to 10 terabytes. They have billions of requests. They each needed a sub 200 millisecond response time. And 200 milliseconds is normally the max that any of these apps, but they typically may need less. And then also from a cost perspective, you think about the masters of the internet or masters of caching, NoSQL, or relational database, of 2 separate machines. And that means you've always got to roll out machines in pairs. So they had separate caching, separate persistence, and they wanted high availability within a data center and between data centers. And that's pretty expensive. So what we were able to give them was real-time access to those 300 to $1 billion JSON profiles, the agility to change them when other systems changed as well. Again, the sub 200 millisecond response time, but also for mixed read write, we're giving them 5 millisecond response times as well. That's that many systems, when you start doing writes, just die. So the analogy we have about mixed read write systems is the system may be like a 6-lane freeway, which is great, and then you've got a train track going across it. And suddenly a train comes across, you don't know if it's a passenger train that's going to take 5 seconds, or a goods train that's going to take 2 minutes, because your whole system just locks. So it's very important to be able to give you this kind of performance in both a mixed read-write environment as well. The other thing we were able to do was to what we call layer consolidation, was to take a cache, and really the database is the persistence layer. Instead of having over 2 machines, consolidate it to a single machine. And then give them really simple high availability across clusters within the data center, and do that across data center as well. That has a dramatic impact on reducing cost. It's a lot less hardware. It's kind of interesting to look at the commonality around the stack again. What you're seeing is a batch stack and a real-time stack. And the real-time stack has SQL in it, because that's how you're using That's how you serve up the operational data very quickly, but the Hadoop backend is used for consolidating data from many different sources and feeding it into the NoSQL system for real-time serving of profile data. They also, in this case, it was interesting, they use Elasticsearch, which is also what we're building, to do searching of data and then the text within the data as well. Just added this slide in today because it was great that Christopher's here. Broadwell Education is just a great example of managing content and metadata at global scale. So Christopher can take questions at the end as well. So what they're looking at is the future of education, and how you can serve curriculum up around content around curriculum, metadata around curriculum, and start tracking risks around students. Saying are they going to fail, are they going to success, and then looking at patterns within the student community, the education community, doing this across the US and doing cross-data center replication globally as well. And they said, Christopher's here as well, so Christopher can take questions on that later. So given what we just looked at, as those are pretty common use cases that I think most companies in the world do. So, if you have an internet presence, you're going to have that kind of requirement around global user IDs. If you sell something, you've got to have that. You want to be able to track sessions. You need to be able to cache. You need to be able to expand, maybe not like a games industry, but you need to expand and scale easily without the overhead of SSD cost. So most companies are in this kind of situation that have a kind of a wearable mobile presence. So what I want to look at now is what NoSQL does to support that kind of scalability, performance, and agile changes. Look at what we do. So when we look at here, the first thing from a performance perspective is consolidating the caching layer and the persistence layer. So what we have here is if we have a document in the app server, we write it to the managed cache, and then simultaneously we write it to a write-ahead log on the disk queue, and we write it to a replication queue to always replicate it to one or more nodes within the cluster, and then it gets persisted. So the persistence here is with a single node, and we persist to a separate node within the cluster as well. We do an update, same kind of process. We have an update on the app server. It goes to the managed cache. We write it to the write-ahead disk queue for both our own node and the replicate, one or more replica nodes. And then we persist. If we think about a read operation, what we're able to do now in the managed cache is we have a request for getting a document, and we get it from the cache. You have typically you have very, very fast response rates, and that's how Orbitz gets this response rate on most of the bookings that you get. But then you may want to have a cache miss, so if you get a document, if it's not in the cache, you get it from disk, place it into the cache, then the app server gets it and serves it up. Typically you're going to be able to have a cache hit. So that's one of the ways we get very, very high performance, really through consolidation and caching and persistence. And be able to automatically replicate across one or more nodes, two or more nodes. So when we look at scalability, what we're trying to do now is give you not just scalability, because sharding gives you scalability, but really simple, very easy, very painless scalability that can dynamically grow, as in the case of the OMG POP from 50 to 50 million users in 50 days. Just through a single click of a button, you can add in nodes without having to partition databases, copy them across, and delete them, and basically kill yourself. So what we've got here is the documents distributed across 3 separate nodes, and we evenly distribute them. That's all just done transparently for you. You don't have to write your own sharding, write your own algorithms, it's just done for you. So each server stores both an active document and a replica. And only one server is active at a particular time. So if you want to look at your document 9, the active server is server 1, which is replicating on server 3 in this case. That's all just done transparently for you. So then what we have is, for every client, we have a client library that provides a really simple interface to the database, and we call it cluster map. And all that does is tells you how to find the relevant document in the server that it's on. So for example, the cluster map knows that document 5 is on node 1. You don't write anything in your application. The application just asks for that particular document, and then the cluster map finds it and returns it for you. And yeah, as just shown here, multiple app servers can access the same document at the same time. So we've taken the whole benefit of sharding and made it completely painless. The second thing, which is horribly painful in sharding, is, hey, my business is going great, we've got to expand servers. And then you have to partition databases, split them up, copy them across, and it's just very, very nasty. So what we're able to do here is just with a single click, we can add 2 servers into the cluster. Literally, it's a one-click operation from a GUI. Then, transparently, we automatically rebalance across the cluster. Whilst the cluster is live, and you can see the progression of the documents being rebalanced across the cluster. Then, automatically, the cluster map's updated. And then you can do read-writes or updates to the appropriate node. It just happens transparently through a fully live system. This is all happening and rebalancing as your app is running. The second kind of issue is what happens when a node goes down. So this kind of scenario, server 3, we're accessing the documents, but it crashes. So we have a failure on a node. So we know that because the requests to server 3 have failed. So the cluster detects the server's failed, automatically removes that node from the cluster map, and because we have a replica of every document, we then are able to automatically rebalance those replicas. The replicas become the active masters, and then we copy them to a separate place. So again, we have 2 copies, all done completely transparently. And what we're really mapping in those servers is something like this. So you think about traditionally in a relational database, you're going to do separate tables, and you're going to do joins. The problem is the join is very slow. So if I want to bring up a global user ID in 10 to 100 milliseconds, you're just not going to do that in a relational database, particularly if you have to join 2 tables. So you think about when relational databases were invented, you had a real shortage of CPU and a real shortage of disk. Now we have abundance of CPU and abundance of disk. So what we're able to do is to kind of pre-join information around the user and just serve it up in 10 milliseconds. So these are the kind of JSON documents that we're using. We're really pre-aggregating the documents into a single JSON document, serving it up phenomenally fast without the need for esoteric hardware. So, as I said before, I think the other kind of parallel you can look back to what we had in the 80s is if you were living in that industry, it became really clear a package formed around Oracle, Informix, and Ingress. Those are the big 3. We're seeing a similar kind of big 3 today. It's 10gen. You look at it, just the funding that's going into these companies. 10gen just got massive funding, so has Cassandra, so has Couchbase. So they're getting a disproportionate amount of funding, a disproportionate amount of customers, a disproportionate amount of revenue. And what's interesting on the NoSQL space, so I think you can categorize it as to have different categories. There is graph databases, and really Neo4j is the leader there. Then you've got the columnar family, you've already got Cassandra there. Then you've had historically 10gen with the document system and Couchbase with the key value. And Couchbase is now starting to have key value document store. We believe that's the biggest part of the market. And what we're seeing now is really the expansion from particular use cases that we've discussed to more general usage. And when you move to more general usage that's phenomenally scalable and highly performant, you're going to start eating away at the relational database market. Because for these use cases, it's just not as good. And it's not even close. And when you look at each of these categories, I think each of the vendors and each of the categories has very different approaches to scalability, performance, and data modeling. For example, a graph database is all about traversing nodes where you don't know how to get down the tree, which tree you're going down before you start. And it just has to have a different strategy than phenomenally high-performance JSON-oriented databases. It's different. But that's how we kind of segment the market. We believe it's going to be a multi-billion-dollar market. So the other thing we believe that's really important is you look at the NoSQL market, for all those vendors, they've been phenomenally successful really on the server, on loosely coupled cloud-based architectures. They're really good. And the people really like developing against a kind of JSON model. Like in the 90s, we called it impedance mismatch. But what they're really saying is it's all about objects. It's about, in my app, I've got a JSON object. I want to store that without exploding into a relational database model. So we believe that the NoSQL approach is going to expand from being just on the server to the mobile device as well. And we've been conditioned to have certain expectations around the mobile. You think about a simple thing like Evernote. I mean, it's set expectations for any app. It works online, it works offline. If you work offline, when you sync back online, suddenly everything syncs. And it syncs not just for client to server, it syncs across all your devices. And you can also sync certain folders to other people as well. And most quality mobile apps are going to have that kind of sync-based property. And you think about the kind of characteristics of these apps, you may have one tag or 20 tags. You may have one comment or 20 comments. That kind of fits into a JSON model way better than a relational model. So we believe the future of mobile is going to be around linking JSON-based databases from the mobile device into the cloud. I'd like to really, this is what we recently announced, I'll go through that now. So we believe you're going to have JSON will become the de facto way to model and store this kind of data, and you're going to get JSON on the device, natively, JSON on the wire, JSON in the cloud. And we think this is important for a few reasons. Because developers increasingly prefer modeling JSON and storing JSON. The other kind of big thing is, what happens when you're going to get 8 cores on this? Are we just going to do nothing with it? And the potential is you're going to have more CPU compute on all the mobile devices connected to the cloud and the cloud. So we're going to get new kind of apps that are data intensive running on this kind of device. They're going to need a database. So you're not going to be able to run this kind of apps without a database. And when you're going to discover stuff, these apps that are on your mobile device, you're going to want to share it with other people through a database in the cloud and do it in that secure way. So we believe people don't, A, want to develop JSON on the mobile device, and they don't want to go through these hoops to kind of convert it to a relational database, send it on the wire. They want to have JSON on the wire. And they'll be able to store JSON in the cloud and have a really high performance, easy scalability, flexible data model. The key thing about mobile is you can, like the games industry, you can go from 50 to 50 million really quickly. So you need that kind of easy scalability performance on the server as well. So one of the big things I think is very important is if you take an awesome cloud database and port it to your mobile device, it will be useless. It will take like 20 seconds to boot. So this was a total rewrite. This boots in 50 milliseconds, so it's an ultra-lightweight, secure data database designed and rewritten from the ground up for the mobile device. That's the only way it's going to work. It's native around Android and iOS. You can do things like full indexing and querying on the device to use the compute on the device. And we really believe that there's going to be a whole new generation of data-intensive apps that are going to be running on mobile devices. We can't predict what they are, but certainly when you can do something like this, smart people produce amazing apps on these mobile devices. We believe you're way more productive if you can store JSON locally on the device rather than going to some relational database. And it will give you very, very responsive apps. If you have a great connection, or a slow connection, or no connection, you're going to get awesome response. And that's what people are expecting on mobile apps today. The other kind of thing we want to be able to do is to give you sync capability without having to rewrite your app or go through hoops to do that. So what we have is a sync gateway that the Couchbase Lite connects to. This does things like automatic data synchronization, there's conflict resolution, and we use the same replication technology we use across clusters, also within a cluster, and across data centers. We have a lot of experience around replicating data. We really use that to be able to do that in this kind of environment. The kind of thing is this is really hard to do. And you look at a great mobile developer, he's not necessarily a great database guy. He's not necessarily a guy who does conflict resolution and sync. He just doesn't want to do that. So what we made it was really, really simple. You make a really small modification like a page of code to your mobile app. You get sync and conflict resolution at high performance for free. The other kind of thing which we mentioned was that a lot of awesome mobile developers don't want to install a database or manage a database or install sync and manage sync. So what we've got here is what we call this Couchbase Cloud. So you just can go to a database as a service, which is really for developers to develop mobile apps in the cloud. You don't do anything with the database. You just focus upon your app, a few APIs to get sync, and you're up and running. So we do authentication, we do single-click provisioning. The other kind of cool thing is you can work against this sandbox in the cloud, and you can deploy it against Couchbase on Amazon or an internal system, which is totally compatible. So it's kind of a developer environment. And you get instant access to the database as a service and the sync gateway as well. So for me, it's not just a little bit better, it fundamentally annihilates relational databases. It's like going in the late 80s and doing a query in SQL in 30 seconds. Those guys have waited 6 months for that. It's just fundamentally a step change in shared nothing commodity hardware. You just get performance and scalability with ease, which is a nightmare to do with old-fashioned land-based architecture. We believe that NoSQL, as well as being fundamentally better for these use cases, will expand to mobile, because there's a demand from mobile developers to be able to develop against a local JSON database that works online or offline with consistent performance. All those apps can sync. They need to be able to sync to your server, you need to be able to sync across your own personal devices, because you all have Macs, iPads, and iPhones, and you need to be able to sync and collaborate with other people as well. We think there's an emergence of a new stack. What happens probably once every 10, 15 years, and we see that there is going to be a batch stack, typically driven by Hadoop, and a real-time stack driven by NoSQL operational databases, and the two will interact. And if you look at what Cursor were doing, and PayPal were doing, and most of what we're doing, they're all in that same kind of category. So many apps will use just NoSQL, many apps will use a combination of NoSQL and real-time stack, with a kind of more batch-oriented Hadoop stack. So that's the presentation. If you want more information, I kind of summarised what some of our customers are doing. They have live, there's recorded videos, the slides, which are obviously much longer than what I did, on couchbase.com/presentations. If you want to be able to download the software, it's freely available on couchbase.com/download. You can get access to information about JSON Anywhere on mobile.couchbase.com. You can also download the Android, iOS, and PhoneGap software from that location as well. And the other thing we believe is really important within the space is not just giving availability to software, but education. So we have, if you look to couchbase.com/events, you have Couchbase 101, Couchbase 102, 103, and 104 that train you on how to use the software around how to get it installed, how to use SDKs, how do you do JSON modeling, and how to do MapReduce views as well. And again, we run those twice a week. 101, 102 one week, 103, 104 next week, continuously. And so that's an overview of what we see around these kind of key use cases, how we see NoSQL being better for those use cases. And we believe those use cases will become more and more general, and NoSQL systems are going to start eating away at legacy database architectures that are not as good in a modern commodity loosely coupled architecture. Thank you.
Howells, CMO of Couchbase. Before we continue on, we are giving away 2 really awesome remote control helicopters. To enter, all you simply do is drop your card in this basket, Halloween bucket. Inside the bucket, if you go dig down, there is a whole lot of candy, so feel free. Grab a piece of candy as you put your name in. Please just pass it around the room, and we will give that away to 2 helicopters shortly. I want to give a great big thank you also to AppNexus for this awesome Halloween-themed stage. And let's start with the first question.
How do you address security? Are there any security issues?
We will work with vendors like Adaptive Design to do encryption at the server level, and we're working on putting different levels of security for administrators as well. That's in the Couchbase 2.2, and there's different roles for, so for example, an administrator, you can have like a read-only administrator and then an administrator that can update the system. That was put into 2.2, which just came out. The encryption we do with partners, so we're working on doing more of that in subsequent releases as well. We're already encryption on the wire. We use SSL today, HTTPS, but we're working on more encryption as well. But the server-based encryption we do with partners.
Next question. Sorry, got lights in my eyes, I'm not sure to see you. Way to that.
So when dealing with multiple databases, are there accepted best practices with regards to making sure that your data stays consistent? Meaning, if you saved it to one database but it doesn't save to another, and there's inconsistencies, what's the best way of preventing that?
I mean, within one Couchbase system or completely different database systems?
When you do it across these database systems, what's NoSQL systems?
Different NoSQL systems or one NoSQL system?
Right.
Do you mean synchronizing across different NoSQL systems? To be honest, when we've seen the kind of apps, they've used either just one NoSQL system, they've nearly always one NoSQL system, and maybe one NoSQL system in a relational database. So if you look at QuestPoint, they had SQL Server and us. It's pretty rare we've seen multiple NoSQL systems. And they had different kind of roles. So in that case, they had more BI data in the relational database. Then we were it's kind of called the operational data store. So you have one operational data store that's NoSQL, that's very highly performant and scalable. Then you have different types of data in the relational database. So, but it's nearly always one NoSQL system. And then, sorry, just to be clear, the auto-replication within a cluster between data sets is just completely transparent. So you don't have to do anything for that to happen.
Good, yeah.
So the advantage to running NoSQL on the phone is not necessarily performance, but it's syncing compatibility.
It's both. So if you ask different people, will give you different answers. If you ask a pure developer, they just like be able to just store JSON. And yeah, some people use it just for that, because they don't want to use a relational database. But the other kind of benefits is you're going to be able to store it and get consistent performance with high-speed network, a medium-speed network, and no network. So you always get the same response time. And then if you go offline, you get automatic synchronization to the server across all your own devices, and you can have channels to maybe family photos through one channel for your family, and public photos for everybody through different channels. So it gives you all those things, but I think different people will appreciate different things. I think from the development perspective, what we see as the real potential is people can write these very, very highly data-intensive apps on mobile devices. We haven't seen many of those yet. So over the next 2 or 3 years, I think that's what we're going to enable by having a database on the mobile device. But again, some developers will just use it because they love the simplicity of creating a JSON object and storing it without worrying about it. Does that answer your question?
Yeah.
Next question.
Do you have performance benchmarks on your website?
Yep. So if you go to so there's Yahoo benchmarks, so there's comparative benchmarks. There'll be a new scalability page coming out this week as well. So yes, if you go to the resources section, there is a white paper that is comparative benchmarks by Alfresco. There's some more information coming out as well, yeah.
We've got time for a few more questions. Yes?
What's the status of analysis or analytic applications to sit on the top of Couchbase and do summary statistics or actual statistical analysis?
So maybe talk to Chris about, because they do some analytics on the McGraw-Hill on student usage and then predictive. Really cool apps. So to show predictive analytics on students, they did a prototype on all the baseball stats for pitchers. So that's screenshots. There's some stuff that I did take out of Chris's presentation, which does analytics against Couchbase doing map-reduced views. They've done it for the whole season of baseball stats. It's pretty cool.
In real time.
In real time, yeah.
As the advanced, we simulate that obviously presentation. It allows us to essentially write all the intermediate results from the low-level data all the way up by rolling up them up. So if you want to go to a high-level profile, that's a Couchbase document. The low-level embed is also a Couchbase document. So we basically do kind of Excel dependency mapping. So it's like what document changed at this bottom level, and what the next document I need to rerun the MapReduce to create, stick it back in Couchbase, and that will turn it the next level up. So that allows you to key value store as a dynamic programming kind of environment, and your access time for any of the levels of access is going to be 5 milliseconds to 200. But then your latency will be a little higher. That's real times, near real time. So a lot of times that's good enough. If you don't need to do training system when you're talking about like less than 10 milliseconds, you can actually use the MapReduce wheel as a way to get there. So it's an interesting merge between transactional system and analytic system. And Couchbase is a really good flexible platform. My talk, which is on the presentation website, detailed how we did that and the code that we used to show the baseball data and so on and so forth. Thank you, Ron.
And again, like personally, this is not real-time analytics, but I encourage you to look at, there's a 30-minute video of Patrick presenting that as well.
Does it replace data warehouse in any capacity, or would you need both depending on, what your operating models are?
So I think one way to look at the overall database market is when you look at the old and you look at the new. So the old market had relational databases, which were really online transaction processing. And then you had data warehouses, which either VI or data warehouses depending on the scale, and you had ETL in the middle. So if you roll that forwards, And the other key thing is the biggest part of that market is the OLTP market. So if you roll that forwards, I think what we're seeing is, instead of modeling banking transactions, we're modeling interactions of the mobile phones. It's just phenomenal throughput. That's an operational database. So you go from OLTP relational database, the modern equivalent is an operational database, which is going to be NoSQL. I think the modern equivalent of the data warehouse is going to be much more Hadoop-based. And the modern equivalent of ETL is going to be something like Scoop, or you may have real-time Kafka feeds going through. So that's how I kind of map out the market. And I think the biggest opportunity is for the NoSQL players, because they're going to erode the biggest part of the existing LTP market.
That's very elegant.
Yes?
You mentioned how painful it is to do sharding of a relational database. But given that NoSQL systems don't have to resort to sharding until they're much, much larger, but does a NoSQL system solve the problem of sharding any better than relational databases do?
So if you look at relational databases, it was kind of interesting. So I think one of the things that opened my eyes to how people look at relational databases was the guys that wrote Gig. And their architects presented about how they could shard the Dig scalability across many, many nodes, how they use memcached. But they fundamentally wrote the algorithm for sharding themselves. So the pain is that you can shard that you write what we've done out of the box yourself. And the real painful thing is, say if you run out of scalability, maybe you have A to H and I to Z here. And suddenly you need to add a third node. You need to rewrite your application to go A to D, D to H, I to Z here. And you have to rewrite your app. You have to then take the database and manually partition it and rebalance it. You just don't need to do that in NoSQL. And the reason that's been put into NoSQL is because we know the pain people have gone through by manually managing standard relational databases and manually sharding them, and then manually changing the apps. West Point was that a good example of that. It was just the polite word they used was it was a headache. So absolutely you can do this, but it will be a nightmare. And that's what's really driven the nightmare usage scenario of relational databases, and the requirement for scalability and performance is what's driven the widespread adoption of NoSQL in general. It just does it. It was designed from day one to auto-shard on commodity hardware.
So a hand halfway up over there.
I think you answered at the end. Just to clarify a point. I think the question was, the issue with Couchbase is not that it can handle a lot before you need to shard it, but that fundamentally it's a sharded architecture at a very deep level. So everything about it is sharded from day one.
I think the other kind of important thing, which is kind of unique to us because of our memcached key heritage, is sharding is great to get really simple scalability across nodes, but for performance, being able to merge two separate layers of memcached and MySQL into a single layer gives you really, really simple, good performance as well. And you have much less hardware.
Okay, we got time for just one more question. Okay. So you on her hand. Okay. Anybody? Okay. So, yeah, we're going to move on to the raffle. Thank you. Before we grab the raffle, give a great big round of applause, Dr. Ian Howells. And now we're about to give away 2 helicopters. Would you mind please mixing it up, and you might make some candy in there, it's all right. All right, now without looking, just reach in. Is that yours? Okay, open up, read it out. Oh, it's a big piece of paper. Right next to you. All right, let's pick someone else next. For the next one, let's go somewhere far back. All right, mix it up, please, and then, without looking, close your eyes, pull one out, and read it out. All right, man.